Okay, now is the last part of integration, which is the applications of integrations. So we'll just go to the one application only, which is called finding area. Okay, so the definite integral represent the area between the function f(x) and the x-axis along the interval. Okay, there are a few types of it. Okay, if you can see here, sorry. So f(x), so you refer the line f. So it's in the blue color here. So it's this graph. Okay, it is graph f in the blue color. So if we integrate from a to b of fx, meaning the graph f, so it means that is the area under the f, under the graph f, between a to b. Okay, from a to b. So it's just the uh, area here. Okay, in the purple color. Okay, the same thing if we have gx here. Okay, if we integrate from a to b of gx here, is actually we want to get the area below the graph. Okay, g to x axis, the same thing just now, also x axis, from a to b. Okay, from a to b. Okay, but we can also find the area between the two graphs. For example, okay, area between f and g. So the upper curve you see here between g and f, okay, the two graph here. So the upper curve is the f. So f will minus g. Okay, so the area between those is this one. So basically, if you want to find the area of a graph, we need to know the location of the graph. Then only we can sketch and we can find the integration. Okay, now we want to find the area bounded by the curve y and the x-axis along the interval 3 to 5. So here it's already given the y. So y is this one. So the area is equals to integration of from a to b of fx dx. Okay, so your fx now is equals to y and your b is 3, 5. So area is equals to from 3 to 5. We only want to know this area only, 3 to 5. The function is given x minus 2 power 1 over 2 dx. So if you integrate this function, you will get the value or the area of this region. So now let us integrate this. X minus 2, 1 over 2 plus 1 will be 3 over 2. Divide by 3 over 2. The function is from 3 to 5. Okay, so now before we substitute the limit, I continue here. Maybe you can simplify. It will be 2 over 3 x minus 2 power 3 over 2 of from 5 to 3. So you have learned on how to solve definite integral, right? So the upper limit will minus the lower limit. So it will be 2 over 3. 5 minus 2 is 3 minus 2 over 3. 3 minus 2 is 1. Okay, so make use of your calculator. and you'll get the answer. So the answer is 2.80 unit square. Okay, that's it. So we'll try to look at the next example. So now find the area bounded by the curve y equals to x squared minus 4 and the x-axis along the interval 0, 2. So it's in the green region here. So let us integrate this one. So now it's the x-axis to the curve. So it's a negative. If you find from 0 to 2, it's be like this, right? So now area is equals to the x-axis is equals to y equals to x. Sorry, y equals to 0. Y equals to 0 here. Minus is between two curves. You imagine as two curves. And this curve. So the upper curve is y equals to 0. And the lower curve is y equals to x squared minus 4. So the error is from 0 to 2. 0 minus x squared minus 4 dx. Or you can just assume it as negative. Okay, because it's below the graph. So 0 to 2 will be negative x squared plus 4 dx. So to get the one in the green area, so we just integrate it. So negative x power 3 over 3 plus 4x from 0 to 2. So now, substitute the limit. Minus 0. So the answer would be 16 over 3 unit cube. Okay, we look at the next example. So now we have two curves here. So we need to find the intersection point of A and B. Okay, there are two intersection points here. So the intersection point is the limit to determine the limit. So let us find the intersection point first. So how to find it? It occurs when the two curves have same value of x and y. Okay, so y1 equals to y2. So 2x power 3 minus 3 equals to x. So use your knowledge on how to solve this. So you can just use your calculator to get the x. x1 equals to x2 equals to 3 over 2 and negative 1. So meaning it's negative 1 here. Here is 3 over 2, the intersection point. So now it's between two curves. So it will be the upper curve minus the lower curve. So what is the upper curve here? So it's the straight line here, right? So straight line here is equals to y over x. The lower y equals to x. The lower curve here is this one, y equals to 2x squared minus 3. So your integration would be the area is equals to integration of from negative 1 to 3 over 2, because that's the point of intersection. Point intersection determine the limit. Now the upper curve is the x, okay, minus 2x power 2 minus 3. Don't forget the bracket, okay, because it's minus the whole thing. So now your area is from negative 1 to 3 over 2, x minus 2x squared plus 3 dx. So you just need to integrate these. So when you integrate this, you'll get negative 2x power 3 over 3 plus x squared over 2 plus 3x from negative 1 to 3 over 2. So now substitute the limit. 3 over 2 power 3 plus 3 over 2 squared over 2 plus 3 times 3 over 2 minus negative 2 times negative 1 power 3 divided by 3 plus negative 1 squared 2 minus plus 3 times negative 1. This is okay. Simplify and you will get the answer. 3.375 minus negative 1.83. So the final answer will be 5.205 unit cube. Okay, that's it. Okay, now for this question, there's no sketch given, so you need to sketch by your own self. First all, we need to find the point of intersection first. So again, to find the point of intersection, we let y1 equals to y2. Okay, y1, y2. So y1 equals to y2. So x squared equals to x. So x squared minus x equals to 0. X minus 0. So x must be equal to 0. X equals to 1. So if you want to sketch the graph, okay, x, y. So the intersection point is 0 and 1. Sorry. 0 is here, okay? Negative 1. Okay, let us sketch y2 first. y2 is a straight line that goes through the origin. So this is y2 equals to x. So y equals to x squared, y1. So if x 0, y 0. If y equals to 1, and x equals to 1, y equals to 1 too. Okay. Okay, it's the same thing here. So it's actually this graph. Something like this. Actually, I'm not really good at sketching graph. Oh, so bad. Okay, like this. So this is the area that we want to find. So the intersection is 0 and 2. So your A equals to 0, B equals to 1. So this is 0 and 1. So this is the upper curve minus the lower curve. So this is y1 equals to x squared. So the upper curve is a straight line, y2 equals to x. So it will be x minus x squared dx. Don't get it wrong, yeah? If you choose wrongly, the answer will be wrong. So from 0 to 1. So when you integrate x squared over 2 minus x power 3 over 3, 1, 0. So when you substitute the value, so the answer will just be 1 over 6 units cube. Okay, that's it. So the important thing is you need to know how to find the intersection point, and then sketch the graph to know which is the upper curve, which one is the lower curve, and then you have to integrate in the area formula which the upper minus the lower, and substitute the limit from 0 to 1 here, and just integrate it. Okay, that's it. So please try to do this exercise and submit it to me. Okay, there are only 2 questions.